Alright, so in this problem I have 2 to the power of x plus x equals 5. So I'm going to first start by subtracting x on both sides. So these two cancel out, and I get 2 to the power of x is equal to 5 minus x. Now, I'm going to divide both sides by 2 to the power of x. So these two cancel out, and I get 1 is equal to 5 minus x over 2 to the power of x. Now, this is the same thing as negative x plus 5 times 2 to the power of negative x. And if I multiply both sides by 2 to the power of 5, I get 1 times 2 to the power of 5 is equal to negative x plus 5 times 2 to the power of negative x. And 2 to the power of 5 is 32, so I get 32 is equal to negative x plus 5 times, sorry, I forgot to multiply this side by 2 to the power of 5, but 2 to the power of negative x plus 2 to the power of 5 is 2 to the power of 5 minus x. Now I have 32 is equal to negative x plus 5 times e to the power of ln of 2 times negative x plus 5. And now this is the same thing as negative x plus 5 times ln 2 e to the power of negative x plus 5 times ln 2 is equal to 32 times ln 2. So I just multiply both sides by ln 2. And now if I take the W Lambert function on both sides, and if you don't know what this is, I highly recommend researching about it. But after that's done, I'm going to be left with negative x is equal to negative 5 plus w of 32 ln 2 over ln 2. And meaning x is equal to 5 minus w of 32 ln 2 over ln 2. Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So to solve this, I'm going to divide both sides by x to the power of 2. So then these two cancel out, and I have 1 is equal to x to the power of x over x to the power of 2. Now if I have something from a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2, this is going to equal x to the power of x minus 2. Now if I take the ln of both sides, I get ln of 1 is equal to ln of x to the power of x minus 2. Now if I have something in the form ln a to the power of b, I can move this exponent b to the front, so it's going to equal b times ln a. So now I can move x minus 2 to the front, so now I have ln 1 is equal to x minus 2 times ln of x. And ln of 1 is equal to 0, so I have 0 is equal to x minus 2 times ln x. So now this actually gives me two equations. I have x minus 2 is equal to 0, and I have ln of x is equal to 0. So for x minus 2 equals 0, this is pretty simple. All we have to do is add 2 on both sides, and we get that x is equal to 2, and for ln x equals 0, well, ln of 1 is equal to 0, so x is equal to 1. So my two solutions are x equals 2 and x equals 1. Alright, so in this problem, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So I'm going to first rewrite 9 to the power of x as 3 squared to the power of x, and then rewrite 81 as 3 to the power of 4. Now, this is the same thing as 3 to the power of x to the power of 3 minus 2x is equal to 3 to the power of 4, because 3 to the power of 2 to the power of x, that's going to equal 3 to the power of 2x. And now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, x to the power of 3 minus 2x is equal to 4, meaning x to the power of 3 minus 2x minus 4 is equal to 0. So now to solve this, we actually have to find one solution of x so we can use that solution to find the other solutions of x. And we actually have to just keep on plugging in numbers until we find a solution. So if you actually plug in 2, you get that that the solution equals 0. So x equals 2 is one solution of x. And now using the solution, we can find the rest of the solutions by doing long division. X minus 2 equals 0 is a solution. So meaning we have to divide this by our original equation. So we have x to the power of 3 minus 2x minus 4 divided by x minus 2. And if you do this, you end up getting x minus 2 times x squared plus 2x plus 2 is equal to 0. So now this gives me two equations. I have x minus 2 is equal to 0, and I have x squared plus 2x plus 2 is equal to 0. So for x minus 2 equals 0, x is obviously equal to 2. And for x squared plus 2x plus 2 equals 0, I can use the quadratic formula. So I get x is equal to negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, all over 2a. This is equal to negative 2 plus or minus the square root of negative 4 over 2, which is equal to negative 2 plus or minus 2i over 2, which is equal to negative 1 plus or minus I. So these are my three solutions to this problem. Alright, so in this video, I'm going to solve the problem 32 to the power of 200 minus 2 to the power of 999. So to solve this, I'm going to first rewrite 32 as 2 to the power of 5. So I get 2 to the power of 5 to the power of 200 minus 2 to the power of 999. And this turns into 2 to the power of 1000 minus 2 to the power of 999 because the 5 and 200 multiply. Now to solve this, I'm going to rewrite 2 to the power of 1000 as 2 to the power of 99 plus 1. So I get 2 to the power of 999 times 2 to the power of 1 minus 2 to the power of 999, which is equal to 2 to the power of 999 times 2 minus 1, which is equal to 2 to the power of 999. Alright, so in this video, I'm going to solve the equation 1 to the power of x plus 10 to the power of x is equal to 100 to the power of x. So, to solve this, I'm going to first start by rewriting this as 1 to the power of x plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, I'm going to look at the term 1 to the power of x. Well, let's say we have 1 to the power of any number, like 1000. This is still equal to 1. And even if we have 1 to the power of infinity, this is still equal to 1. So no matter what value x could be, it's still going to be 1 to the power of x will still be equal to 1, meaning we can just ignore the x and just say this is 1 plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And a to the power of m times n is the same thing as a to the power of n times m. Well, if these two are the same, and a to the power of m times n is equal to a to the power of m to the power of n, then this should mean that a to the power of n times m is equal to a to the power of n to the power of n. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So for 10 to the power of 2 to the power of x, I can switch the values of 2 and x. So now I get 1 plus 10 to the power of x is equal to 10 to the power of x to the power of 2. Now from here, I'm going to let 10 to the power of x equal to the variable y. So if I substitute in y for 10 to the power of x, I get 1 plus y is equal to y squared. Now I'm going to subtract y and 1 on both sides. So I get y squared minus y minus 1 is equal to 0. Now, what we have here is a quadratic equation. And to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I'm going to look at the coefficients. A is 1, b is negative 1, and c is negative 1. So I get y equals negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And now this is equal to 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So I get that the value of y is equal to 1 plus or minus the square root of 5 over 2. However, we aren't done yet, because remember, we're solving for the value of x and not y. And we let 10 to the power of x equal to y. So I get 10 to the power of x equals 1 plus or minus the square root of 5 over 2. Now, this gives me two equations. I get 10 to the power of x is equal to 1 plus the square root of 5 over 2, and I get 10 to the power of x is equal to 1 minus the square root of 5 over 2. So I'm going to first start with 10 to the power of x is equal to 1 plus the square root of 5 over 2. Well, to solve this, we want the x over here, which is an exponent, to turn into an actual term. And to do that, we're going to use logarithms. So I get log 10 to the power of x is equal to log of 1 plus the square root of 5 over 2 when I take the log on both sides. And now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So I can move x here to the front, and I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. Now, I'm going to divide both sides by log 10 because x, we want to isolate x. So these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. Now, if you already didn't know, log 10 is equal to 1. So x is simply equal to log of 1 plus the square root of 5 over 2. And now the exact value of this is 0.209. So this is one solution of x. However, don't forget that we have the equation 10 to the power of x is equal to 1 minus the square root of 5 over 2. So to solve this, we're doing the same thing. We're going to be using logarithms. So I get log 10 to the power of x is equal to log of, this time 1 minus the square root of 5 over 2. Now I can move x down, so I get x times log 10 is equal to log of 1 minus the square root of 5 over 2. And we don't even have to divide both sides by log 10 because we already know log 10 is equal to 1. So we can just get rid of it, and I get x is equal to log of 1 minus the square root of 5 over 2. Now, the log of 1 minus the square root of 5 over 2, the exact value of this is actually going to be negative 0.209 plus 1.364i. So there is an imaginary number in this. So this is my second solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Thank you.